Hello, my dear lovely viewers. Good day to you all. You're welcome to today's class. I remain your tutor, Aisha Bande. So, today's class is proudly sponsored by Project Connect. Project Connect is an application for undergraduate university students. If you want to know more about the app, kindly go to the Play Store on your Android phone and search for Project Connect as written on the board for you to get started. And if you want to know more about this application, kindly send me a DM and we discuss from there. So today we shall be looking at a past question from Federal University Lokoja in Kogi State, Nigeria. We'll be looking at a past question from 2021-2022 from the Faculty of Sciences, Department of Mathematics. The course code is MAS 203. So I'll be solving the question 6A, which reads that we should show that the series 1 plus 2 square over 2 factorial plus 3 square over 3 factorial plus 4 square over 4 factorial plus dot 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 is convergent. So we have been given a hint for us to solve this question, and the hint says that we should use what we call the ratio test. So we can use this ratio test to know or to check if the series we have in this question is a convergent series. But before I begin solving, I'd love to explain or bring in one or two things we need to know on this. If limits as n tends to infinity, absolute value of a subscript n plus 1 divided by a subscript n. So we take the absolute value of this. If this is equal to L, and if we have our L, if L is equals to 1, we say that the series is inconclusive. Okay? Either factorial or of exponents, or the last one is n to the power of n. So any of these three. So the question we have today is a series that comprises of what? Of factorial. So let's get started. So let's get the value for our an from this question. We can see that an is equal to n square over n factorial. Okay, where n can be any of these values we have here. So what this interprets to this, okay? So our an, a subscript n plus 1 to n plus 1 square all over n plus 1 factorial. Okay, so from here now, all we need to do is to divide this, what we have here, that is a subscript n plus 1, we divide by a subscript n. So let's continue. So here we are going to have the absolute value of a n plus 1 all over a n. So now let's impute what we have. So this an plus 1 is what we have as this value here. So this is n plus 1 raised to the power of 2 all over n plus 1 factorial divided by, so we're taking the absolute value, divided by an, which is n squared over n factorial. Okay, so from here we keep simplifying. From here, so this is equal to, this is the same as saying n plus 1 square over n plus 1 factorial. So this is the division line here. So this is divided by n squared over n factorial. So mathematically, this is the same thing as saying n plus 1 square over n plus 1 factorial. So the division becomes times, then the denominator becomes the numerator, and vice versa. So we have n factorial over n square. So we simplify further from here. We have that n plus 1 all square over n plus 1 factorial is the same as saying n plus 1 times n factorial. Okay, so times n factorial over n square. N factorial cancels out n factorial. So n plus 1, one of this cancels one of this. So what we have left is n plus 1 over n square. So looking at this, simplifying this is the same as saying n div over n square plus 1 over n square. One n can cancel, so one of this n cancels this n. So what we are left with is 1 over n plus 1 over n square. So what we are having now is 1 over n plus 1 over n square. So at this point, we can take our limits as n tends to infinity. And if as n tends to infinity, here one over n becomes 0 plus 1 over n squared also becomes 0. And 0 plus 0 gives us 0. So this shows that our answer is 0. And we know that 0 is less than 1. So that means that L is equals to 0. So remember from the explanation I made earlier, I said whenever the value of n is less than 0, it means that that series is convergent. So you say, therefore, the series is convergent. Okay. So it's just as simple and as straightforward as this. Okay. Kindly go to the Play Store on your Android phone and search for Proj Connect. This application is for undergraduate university students. For more information, kindly come to my DM. Let's discuss. God bless you all, dear viewers. See you in the next class and bye for now. I remain your tutor, Aisha Vendi.